Hello, everyone, and welcome to the second session in our Soybean Innovation Lab Multi-Crop Thresher Webinar Symposium on Profitability. My name is Amy Karyanikis. I'm the Communications Manager for the Soybean Innovation Lab, and I'll be your moderator today. Today's webinar is sponsored by the Feed the Future Soybean Innovation Lab, focused on improving soybean production and utilization across sub-Saharan Africa. Today, we are joined by registrants from 32 different countries, representing organizations within the private sector, academia, development agencies, and research institutions. Big welcome to everyone here with us today. So before we begin, I would like to give everyone a quick overview of the GoToWebinar software, which you can use to ask questions and access webinar resources. Whether you're using the desktop or web application, you'll see a questions pane on your control panel. Please type in your questions as they arise, along with your organization and country. We will collect all of your questions and address as many as possible during the question and answer session at the end. Questions that are not answered during the webinar will receive a written response after the webinar has concluded. Also on your GoToWebinar control panel, you'll see a handouts pane. Expand this pane to access important handouts and the webinar presentation in its entirety. Depending on your connectivity, you may experience a lag in the transition of slides. This presentation is available as a PDF in your handouts pane, so please feel free to download it now and follow along at your own pace. I'd also like to note that today's webinar is being recorded, and a copy of the recording will be sent to you following the webinar. So now I'd like to go ahead and introduce you to our panelists. We have the Director of the Soybean Innovation Lab, Dr. Peter Goldsmith, with us. Thank you, Dr. Goldsmith, for taking the time to join us today. We also have Dr. Edward Marty, an economist and researcher from the Savannah Agricultural Research Institute, joining us from Yangpala, Ghana. Thanks, Dr. Marty. Okay, and we are very excited to have Mr. James Daka with First Wave Group, joining us from Lusaka, Zambia. And thank you for being with us today, Mr. Daka. Okay, so before we get started, I'd like to go ahead and launch our first interactive poll. We use these polls as a way to get your feedback and to get a better understanding of our audience. Okay, so for our first poll, we'd like to know a little more about who's joining us today. So please identify which category best describes where you work. Do you work for a private company? Do you work for a non-government organization? Do you work for a government agency or a university or maybe something else? We'll give everyone a few moments to record their answer. Okay. And we'll be closing the polls in 3, 2, 1. Okay, let's see here. I'm going to go ahead and share the results. Okay, so thanks everyone for your feedback. It looks like the majority of you work for a non-government organization. This is good to know. It's always nice to get a little background on the attendees joining us for each webinar, so thank you for participating. Okay, so now I'd like to go ahead and turn it over to Dr. Goldsmith and Dr. Marty to kick off our presentations. Dr. Goldsmith, feel free to begin whenever you're ready.
Super, thanks so much, Amy. Pete Goldsmith here. It's a pleasure to be visiting with you. I'm a professor at the University of Illinois, an agricultural economist. I direct the Food and Agribusiness program here at the University of Illinois and am the director of the USAID's Soybean Innovation Lab. We're going to talk today about the profitability, some of the economics behind SIL's Multi-Crop Thresher, and it'll be a tag team approach. I'll do some introduction, hand off to Dr. Marty, and then he'll throw it back to me for the final wrap up. Next slide, please. Yeah, so our setting, the thresher, the multi-crop thresher has been in development for a number of years, beta testing and a number of prototypes and demonstrations and trainings and so on and so forth. We're now at the commercial scaling phase of the innovation process, as the threshers are now being bought and being used by commercial operators. So these are the first data, and we wanted to share those first data with you. The data we're going to talk about today comes from commercial activity in Ghana, where there are 8 threshers, thresher operators that we visited with, as well as in Zambia, 17 thresher operators as well. Most of the operators and these operating companies have been in business, most of them a year, a couple of them 2 years. So this is exciting to get insight into the commercial scale up. Next slide, please. So it's important to understand how the commercial sector, the private sector, is using and operates these threshers. So there's essentially 2 different models underway. There's the owner-operator model, where someone buys a thresher and then operates it, hires labor, and operates it as a sole entrepreneurship kind of business. Alternatively, reflecting a big issue with a capital good like a thresher is credit. And so finding capital to both build the thresher and then purchase a thresher is a significant constraint feature of the economics of a multi-crop thresher. So there are 2 other models where you have an owner who is not the operator but hires an operator, and then the owner who leases the threshers out to others. And Mr. Daka is going to talk about that. It's a great model used in Zambia. Next slide, please. So there's a rated throughput of the thresher, and it's important to know that the thresher engineering standard varies by crop. Some crops flow through and thresh very quickly, while other crops do not. The multi-crop thresher handles a number of crops because the business environment, farmers are farming a number of crops. So maize, for example, and rice flow very quickly, and threshing is in a very efficient process, rated at about 2,000 kilograms per hour, while the soybean, where you're putting in a whole plant, so the biomass to grain ratio is much higher, is about a tenth as fast in threshing. Next slide, please. So in our economic example that we're going to present to you, you can imagine, and this is based on the data of the threshers that we have been following, these commercial threshers. Threshing is about an 8-hour day. About 6.5 hours are for threshing, and 1.5 hours are for transport. Of course, the less you thresh and the more you have to transport, the less efficient the thresher is in terms of profitability. Next slide, please. So there are 2 general operating models for the thresher. In scenario 1, we see operators who move the thresher from field to field or from farm to farm. They could move it using a moto, a small motorcycle driven hauler. Draft is quite common currently in Zambia, draft animals. The thresher does fit into the back of a pickup truck and can be hauled, can be pulled certainly by a tractor. And we have also designed a trailer so that it is legal to be on the road hauling a thresher in a trailer. So you can go from farm to farm. In this scenario, there would be more time on transport, less time relatively on threshing. but this is a common approach. Next slide. The second scenario says that the thresher is essentially centrally located, and farmers bear the cost of bringing the crop to the thresher. And here, in the example, you have 4 farms bringing crops, their various crops, to a central location for threshing. And there can be certainly an economy here by centralizing the thresher. Next slide, please. So location really matters in threshing. So in both models, whether it be the central location or the farm-to-farm model. So there are 3 Ds to thresher efficiency. Distance is kind of the enemy of efficient threshing. Greater distances require more time, more fuel, and more labor, more costs, non-threshing related costs. There's also density in crop types. So it's a multi-crop thresher, which is a great thing, very essential, but there's switching time going from maize to soybean to rice to maize and so forth. And so having larger volumes of crops assembled and having longer run times with a specific crop is more efficient than constantly switching. So density of the crop type matters. And then there's density of crop yield. Putting a soybean plant that yielded 2 metric tons per hectare is much more efficient than putting in a soybean plant that yields 500 kilograms per hectare. Maize that has ears that are more full, larger kernels, and that all relates to the biomass to grain ratio. Ideally, you want a very low ratio. The lower the ratio, like putting in an ear of maize, the thresher operates more efficiently, and more grain can be threshed for a fixed amount of time. Next slide, please. So I'm going to hand it off now to Dr. Marty to talk about the cost of threshing. Edward?
Yeah, thank you very much, Pete, for that great introduction. So at this stage, we want to talk about the cost elements for operating the multi-crop thresher within a steady area. So this cost is based on 8 Ghanaian operators in the Upper West and Ashanti region, and also 1 in Northern region. So this cost is based on the average for all these the 8 Ghanaian operators of the multi-crop thresher. So the first cost element has to do with the transportation. So just as Pete rightly said, usually the multi-crop thresher is transported to the field either by a tractor or in a motor tricycle, and the daily cost is $8.17. Next slide, please. Then also we have the fuel, which constitute about $5.23 within a day. We must also emphasize here that the fuel usage is actually a function of the yield, as well as the moisture content. If you have grains that has a lot of water inside, threshing becomes very, very difficult, and that also translates into higher cost of fuel. Similarly, the efficiency, in terms of the operators, one thing that we realize is that there is a lot of idling, especially with soybean, regarding those that feeds the soybean into the multi-crop thresher. So if this laborers are not trained well, it also ends up, using a lot of fuel with the thresher. Next slide, please. Then also, you also need to lubricate the thresher, the multi-crop thresher, and the cost, the daily cost for that lubrication is $0.42. Then also the belt. Usually after threshing for a particular point in time, the belts either break and you need to replace it, and that also costs about $2.31. The pulleys do not usually break down often, daily. Sometimes maybe once in a season or sometimes twice in a season. So you realize that we don't have any cost element for the pulleys, but also the bearings, which we call the bolts and the nuts. So that's something that the Thresher operators usually, they kind of change, and it's also not often, but sometimes maybe once in a week. So that brings the daily cost, to 0.05, which is a bit low. And we have other maintenance costs as well, which cost about $0.99. Next slide, please. We must emphasize that labor constitutes the higher proportion of the daily cost of operating the Thresher, because usually the operator uses about 4 laborers a day, and it pays them at 5.27 per person a day, and that brings the total cost of labor to $21.08. So the total operating cost for operating the multi-crop Thresher brings us to $38.25 a day. But we must emphasize that at this stage, we have not factored in the cost of depreciation and amortization. Next slide, please. So now, if we account for the cost of depreciation using, the straight line method, that brings you to a daily cost of $3.77, assuming that the Thresher usually costs $5,000. So we assume that if a farmer should buy the multi-crop Thresher on a loan and servicing the loan, for 36 months at an interest rate of 15%, that also brings the daily cost to $5.68. So putting all these costs together, that's the total operating cost as well as the depreciation and the amortization cost, brings the total daily cost to $47.70. Next slide, please. Now we want to look at the distribution of the cost. Realize that labor constitutes the higher proportion of the total daily cost. That is about 44% of the total cost of operating the Thresher, which is followed by transportation. You have fuel constituting about 11%, and the rest, you have amortization, the depreciation, then oil and pulleys, constitute the lowest proportion of the cost element. So at this point in time, I just want to hand over to Pete to continue with the economic analysis. Thank you very much.
Thank you, Edward. Really nice overview. So let's now put this into an operating margin framework, those costs. In our example, the threshing was for 6.5 hours a day, and half the day is spent on maize. We're just as an example, and half the day on soybean. If that were the case, with the throughput, there would be about an average yields level in Ghana. That would be about 8 hectares worth of maize would be threshed, say, in the morning, and about a half a hectare of soybean would be threshed in the afternoon. About 16 metric tons of grain would be threshed, and the operator revenue would be $188. Generally, currently, practice is that a thresher operator receives 10% of the grain they thresh. So using market value and 10%, we arrive at $188 of gross revenue by the operator. As Edward pointed out nicely, the cost per day, the operating costs are about $38 a day, so that the operating margin is about $150 a day. Now, a thresher season is about 75 days. Whether an operator can operate and thresh 16 metric tons a day for 75 days, that would be 100% capacity, is hard to imagine. We imagine it less. But using this operating margin for a day, you're looking at a very high margin and profitability for the day, operating margin of 80%. When we extrapolate that out to 75-day harvest season, you're talking about $14,000 of revenue, $3,000 worth of direct costs, and an operating margin of $11,000 using that 80% margin rate. Edward pointed out that there is depreciation and amortization that covers, that's per day, every day of the year, not just during harvest season. So that's another $3,000 of cost. So the total cost to operate the thresher at this stage, from the early returns from the new operators, is about $6,000, a net margin of about $8,000 or 55%. Next slide, please. So to conclude, clearly the thresher is highly profitable, and this is very consistent with what, just anecdotally and also in surveys of operators, it is a very effective machine and relieves a lot of bottlenecks. Maize is significantly more efficient to thresh than soybean because of the nature of the material entered into the thresher. Right now, mechanical threshing is very new, so there's very little competition. So we imagine margins falling over time. Also, operators will have to maybe travel further to find clients and so forth with greater competition. Currently, operators charge the same price for all crops. Maybe in the future, we might see discounts for high throughput crops, charging farmers less, say for maize customers. Next slide, please. The second conclusion is that there's not a lot of experience mechanically threshing. Almost all soybean, for example, are threshed by hand currently in sub-Saharan Africa, and so mechanical threshing is novel. Operators and farmers are new to this, so farmers in getting their crop threshed and operators actually doing the threshing. So we're going to see the system evolve in terms of improving efficiency. We'll see operators optimizing, trying to minimize their travel. Operators and farmers are going to start to minimize the switching among crops. Monday might be a maize day and Tuesday might be the soybean day. And we'll see operators looking and ranking customers with more preferred customers who have maybe trained labor, high yield, close proximity, things like that. And then there's price discovery underway on what is a fair price for threshing, what is a fair price to transport, what is a fair labor rate. And so price discovery is underway in this new commercial setting. Last slide, please. And finally, the evidence is showing an elimination of this significant bottleneck for the soybean industry. Farmers were unable to plant extensively soybean, for example, because the labor requirement to thresh was so burdensome. Crops were staying in the field for long periods of time. There were all sorts of bad outcomes from manual threshing, and the multi-crop thresher addresses those. It's profitable for the operator. It returns earnings back to the owner. The farmer is successful, so that all the actors along the supply chain are benefiting. So it's really an exciting time. We're going to continue at the Soybean Innovation Lab working with our partners to collect the commercial evidence about their experiences, and we'll communicate that back to you. But the early evidence is quite positive of high levels of profitability and success. So thank you very much, and turn it back to you, Amy.
Great. Thank you, Pete and Edward. That was a great overview. Now that you, all of our audience are experts on the economics of the SIL's multi-crop thresher, we do have another question for you. So I am going to go ahead and launch that. Okay, so our second interactive poll asks, what is the biggest economic constraint or challenge regarding the SIL multi-crop thresher? Please select only one response for this question. We'll give everyone a few moments to record their answer. Okay, and we'll be closing the polls in 3, 2, 1. Okay, and I'll go ahead and share these results with everyone. Okay, so many of you feel that the cost of purchasing the thresher is the biggest constraint or challenge. You know, this is true. As Peter and Edward mentioned in their presentation, labor makes up 44% of the multi-thresher's daily operating costs as well, and then followed by the cost of transporting the thresher from field to field at 17%. So thank you very much for participating in our poll. These are really helpful to get your feedback. Now I'd like to go ahead and turn it over to Mr. James Daka, who will be providing us with a private sector view on the profitability of the multi-crop thresher. James, you can come on, there we go. And you may begin whenever you are ready.
All right, thank you so much, Amy. Hi, everyone, it's good to be here. I think Pete and Edward have done a great job running us through basically the composition of the multi-crop thresher and the economics based on experience from our other partners as well. Like Amy mentioned, I'm joining you from First Wave. First Wave Group is Africa's leading aquaculture firm, and our mission is to provide abundant supply of affordable protein in Africa's growing community. We're doing this currently through aquafeed, fish production and distribution and retail of fish feed and fish in Southern and Eastern Africa. So 90% of the raw materials we use in feed production are sourced locally, and of the 90%, 50% of it is soya. So in 2019, we undertook a 3-month-long study to sort of get first-hand information on some of the challenges that the smallholder farmers were having regarding the production of soya, and we identified the need to improve harvesting and input technologies to increase the soya quality and harvest yields as well. Next slide, please. So after identifying this, we introduced a fleet of multi-crop threshers as a solution to address the following. First, to improve the harvesting techniques used by our farmers, like Peter highlighted in his presentation. Currently, small-scale farmers use sticks. They beat the soya, then start cleaning after. The challenge with this is you'd find that the soya mixes with the soil, so the quality of the soya is compromised. Those that can afford to hire a tractor and run it over the crop and then do the cleaning thereafter. The second solution was that also help us ensure that we procure the needed tonnage of soya. If we increase the rate of threshing, it means we'll also be able to get the much needed crop for each season. The last one was basically a transfer of skills to ensure that we train our local blacksmiths and engineers on how to build multi-crop threshers and also maintaining them. So based on this, we partnered with SIL to conduct thresher fabrication training in Zambia, and a total of 17 threshers have been manufactured this year. Next slide, please. So based on our experience this year being the first year of us operating these threshers, we have discovered that there are actually 3 revenue options for anyone that owns a thresher. But for the purposes of this discussion, we'll mainly focus on the first one, which is the provision of threshing services. This is where we provide services ourselves for directly to the farmers. And the second option is where we lease the unit to a third party. This third party can be an aggregator. This third party can be an organization or a farmer who feels like they need to provide threshing services to their fellow farmers in their location. And the last option that we've come across this year is the complete sale. The complete sale option is where you've got two options. You can sell it for cash or you can barter it with grain. Next slide. So the first question that comes to mind when we're discussing threshers basically is the cost of producing one thresher. So for us in Zambia this year, it has costed us about 3,297 to produce one unit. This includes the training conducted by SIL, the labor, the cost of the engine, and the materials. Under normal circumstances, the cost of training was supposed to be zero, but in our case, we were using a facility that is about 360 kilometers away from Lusaka. So this cost of training includes transportation to the location, accommodation, and all other needed materials for us to facilitate the training. So if you're producing for the first time, in our case, we spent 3,297 per unit, but for future production, we'll eliminate the training cost. Therefore, we'll be producing our units at $2,865 each. Next slide. Basically, Peter has also highlighted on the fact that we've taken an 8-hour day shift for threshing. In our case, we've also taken two limits. The first one is a 25% threshing capacity. We experienced this in the initial stages because it was the first time our team was threshing, so the inexperience is there. Also, we were trying to learn on how best to feed the threshers, particularly on the soya side, because that's where the biggest challenge was. So at 25% threshing capacity, you would thresh about 960 kgs per day at 25%, with your revenue being about $6. In Zambia right now, we are charging about $0.13 per 50 kg bag to thresh soybeans and maize, and $0.13 for maize and $0.4 per bag for soybeans. Your fuel cost there being the highest component, it's about almost 5 liters for you to thresh a ton per day. At this efficiency rate, you'll be able to make a net profit at 25%, a net loss on soybeans of 1.17, and a profit of about $9 on maize at 25% threshing capacity. The other limit is 75% threshing capacity. At this rate, you'll be able to thresh almost 3 tons of soybeans per day, leading you to about $1.6 profit per day as you operate at 75%. If you're threshing maize, on the other hand, you'd thresh about 39.5 tons in a day at 75% capacity, and you'd be able to make about almost $56 in net profit. Next slide. So taking a 24 days working month, 8 hours a day, at 25% threshing capacity, you would basically make you basically take about 17.5 months to get your return on investment. This is if there's no improvement in how you're threshing and you continue to thresh at 25%. However, if you're doing exceptionally well and you're at a 75% threshing capacity, you should be able to get your return on investment in 2.6 months. But bear in mind that at the beginning I mentioned that going forward, our production cost will drop to about $2,865. So therefore, even the duration for you to get your return on investment at 75% drops basically to almost about 2 months. Next slide. going by our experience this year, the service provision option seems to be the most profitable, in that you stand a great chance of recovering your investment within 3 months and still continue to operate and make profits thereafter. The second option of fixed lease, which is a fixed lease option, is still viable. The only challenge with this is right now, because we are just introducing an idea to the community, there's no guaranteed client base as compared to the one under the service provision. The last option, which is the sales option, it appears to be more lucrative. However, in our case, we are trying to improve the lives of the small-scale farmers who may not be financially positioned to afford the threshers, as we are currently selling them for $4,167, which gives you a gross profit of $870. Bear in mind that this doesn't include other selling costs such as advertisement, the after-sales service, and so on. So based on this exposure we've had, some of the lessons that we've learned and the recommendations we'd have are seen in the next slide. Amy, may I have the next slide, please? The cost of production is high if you're buying materials for less than 5 units. So if you're going to venture into production, would recommend that regardless of whether you're fabricating from your premises or somewhere else, you basically try and target to ensure that the initial production is for 5 units, because then you can spread the cost of fuel and all these other components across the 5 units. Then the second component is the cost of the engines, particularly here in Zambia. It's on the higher side, but if you're going to produce and you've got the opportunity to basically source these engines elsewhere, would recommend that you do that. And if you can buy them in bulk, it's even cheaper, because then you need to ensure that the cost of production is kept lower and to enable you a return on your investment as quickly as possible. Then the third lesson that we learned was that moving threshers from one farm to the next, particularly in our case, has been a challenge, as we've had to depend on animals. So what we've been doing to ensure that we do not basically chew into the working hours, would move the threshers the night before to the location where we're going to be threshing the next day. This has helped us a great deal, and it has also given us an opportunity to ensure that we utilize every minute. Then the last lesson is that the labor cost is high. If you're producing outside your own team or premises, if you can manage, it would be advisable for you to basically train your own team. That way you've got a control on production, and also have the production done as close as possible to your premises. These are the lessons that we picked up this year. Thank you so much for listening. And thank you so much for this opportunity. Back to you, Amy.
Thank you, James. That was great. It's really nice to have just a different perspective from First Wave. So thank you for taking the time to be with us today. So we did have one last poll, but we're actually going to skip ahead to our Q&A session. We had a lot of great questions submitted. We want to make sure we have time to answer as many as possible. So I'm going to go ahead and turn it over to SIL's Associate Director, Courtney Tamimi, who will be moderating today's Q&A.
Thanks, Amy. So we've had a lot of really great questions come in, and please feel free to keep typing in your questions. We'll get to as many as we can during the live Q&A session, and any that we don't get to, we will provide a written response via email after the webinar concludes. Before we dive in, I just want to remind everyone that there is a handouts pane on your GoToWebinar control panel. And that handouts pane contains a lot of great resources, including the slides from today's presentations, a briefer on the profitability of the thresher, the operations and maintenance manual of the thresher, and some other good resources. So please be sure to check out that handouts pane and let us know if you have any trouble accessing. And I'll ask panelists to please try and keep your questions or your responses as brief as possible, just so we can get to all the great questions that have come in. So the first question comes from Abdul Wahid Muhammad with the WART group in Ghana. And this might be a good kind of reviewer. And Pete, maybe this is for you. What would be the key indicators of profit and loss when using the SIL multi-crop thresher?
Yeah, the key, it's all about throughput. So getting access and being in a position to thresh significant quantities of grain, and that ratio of threshing to all other time, transport, things like that. So that throughput is the key source of profitability on a fixed asset like a durable asset like a thresher.
Great, thanks. This one's for James. Yergalam Gebremeskel from USAID in Ethiopia wanted to know, from your experience, how long did it take the First Wave team to build one thresher? So to build one thresher unit, the duration.
Well, the first set of 2 threshers that we built took us 2 weeks. Thereafter, we built 15 units in 3 weeks after going on mass production. Yeah. So it's slower at the beginning because that's when you're learning, but thereafter you should be able to produce 1 unit within a week, depending on, it also depends on the labor that you have available.
Okay, great, thank you. This question might be for Pete and Edward. This is from Bekele Kotu with IITA based in Ghana. And he asked, why was the depreciation of the thresher calculated for 3 years? Does that mean that the lifespan of the thresher is 3 years, or can you give a little bit of insight into that?
Yeah, so it's always, there are standards for equipment, especially rolling stock versus fixed equipment and so forth. In this particular case, 3 years seem to be conservative, so you want to always err on the side of being conservative in your estimates. Having the thresher essentially accounted for and reserve set aside for that next thresher for significant repairs, rebuilt, and so forth. So it's a conservative measure. Certainly, we don't know how long threshers will last. We decided to be as conservative as possible. Probably longer, 5 years, 8 years might turn out to be the accurate level, and that would, of course, lower the cost per day. Okay,
great. And I will note that Dr. Marty chatted in that maintenance culture is also an attributing factor to that. This is a question for James. So this is from Dick Tinsley with Colorado State University in the US. He wanted to know if you thought that the size of the SIL multi-crop thresher is appropriate for the field sizes, the spatial layout, and the yields of your farms. And then if the throughput for the various crops was appropriate in your experience.
I would say yes, it is. We're able to, first of all, move it from one point to the next, which is perfect. It's just about the right size. The throughput of the thresher has got more to do with the feeding from the human side. So the output effectively is dependent on the crop variety itself, as well as the available labor and the understanding. Of course, we've also had those questions here in Zambia, particularly from the farmers themselves, that would want to have the feeding point made a bit wider because they think if they push in a lot of soya at a go, then the threshing will be at a faster rate, but it's quite the opposite. So it's basically just about the right size, I would say.
Okay, thanks. And maybe a follow-up to that, that James or Peter, Edward, you could address. Leroy Peterson with Business Development Consulting in the US asked, is the soybean throughput less as a result of the difficulty of feeding the thresher or as a result of the power of the motor?
Yeah,
Yeah,
James,
thank you.
yeah, or Edward.
Yeah, so so from the field, one thing that we realized was that there is a lot of, idling in terms of the the size of the soybean is very small, so it takes a lot of feeding into the thresher as compared to the maize. And it also happens that the laborers who are actually into the maize feeding are more experienced, relative to that of the soybean. So that also kind of affect the level of, the threshing.
Okay, thanks for that feedback. Neil Miller with the organization Tier Fund in the US noted that the 4 laborers that were used in the calculation seemed like a lot. And in their observation, labor was often provided by the customer, which reduced the operator's labor costs. Has that been something you've observed in your research at all?
Yeah, Edward, did you what did you think about that?
Yeah, so with the labor, like we've been saying, so what happens is that usually on the field, when you go do threshing for a particular farmer, they provide their own labor. But sometimes, feeding the system, it's a bit, labor intensive. So you really have to get, about 2 to 3 on the average, to really help with the feeding. So I must say that with the labor, we are also being a bit conservative here, because in other fields, you do more than that. But we must also mention that, where you have a lot of laborers who are actually feeding the system, it's the responsibility of the farmer who actually pays for that. But some of the laborers have to help with the bagging, some have to help with the feeding, some also have to help with the transportation as well.
Okay, thank you. Norman Siekman with the organization Aringa Hope in Tanzania wanted to know if you can estimate the smallholder farmer's willingness to pay per kg. And maybe James, you can talk about your experience with what you're charging farmers, what their willingness to pay is, and Pete and Edward, if you want to chime in with the context of Ghana, that'd be fine too.
So let me come in with the willingness to pay. I think that's a very good question there. It's something that we considered, and for now we've not done that, but it's something that we are considering to actually do. We really want to find out how much farmers will be willing to pay for the threshing. Currently, what is happening is that for every 10 bags that the thresher operator threshes, the operator actually picks 1 bag for every 10 bags. So we also want to find out from the farmer's perspective, how much they will also be willing to pay, so that we can match up, their preferences to that of the operator. Thank you.
And James, did you have anything to add on that? Yeah, go ahead.
Yeah, in our case, farmers have constantly paid per 50 kg bag for threshing services. This is basically based on maize. Threshing soybeans, on the other hand, this is the first time that we've introduced it. And so far, what we are charging, which is 40 cents per 50 kg bag, has been received well, to the extent that we've got a lot of the people that would want us. We had a line of people wanting us to thresh for them, particularly female-headed households in the locations where we're operating from.
Okay, great. David Raystar with the organization Cycle Connect in Uganda wanted to understand if there are any tested business models with cooperatives or farmer groups using the thresher. And kind of a follow-up, are threshers, in your experience and your research, are threshers better handled by individuals or by cooperative group ownership models?
Yeah, I can start, and Edward and James on your experiences. So with the early adopters of the commercial thresher, there have been some groups, and they have, it's a little more difficult in a group, at least early on, maintenance levels, and there's a significant coordination issue related to the thresher. So we would tend to see or expect, hypothesize, that we would see more individual owner-operators or owner-lease sorts of models because the thresher is highly movable from one location, so coordination becomes important. And then, as Edward has mentioned, you want to really maintain the thresher greasing and tightening belts and so on and so forth. And who does that, when and where, and who free rides and so forth. So it may be more difficult in a group. Maybe Edward, did you have more to add from the thresher operators in northern Ghana?
So thank you. That's a very great contribution there. And one thing about the group is that most of them don't actually operate it as a way of, making profit. It's a way of helping one another. So the economics in there is a bit different from individual operators as well.
Great, thank you. Francis Amoa from KNUST in Ghana wanted to ask about the capacity of the thresher for maize, and I know that's more related to the performance webinar we just concluded. But I guess a follow-up for you all was, do you feel that it's feasible for laborers to work 6.5 to 8 hours continuous without rest as used in your economic analysis? Maybe is that what you saw with your research? James, is that what you've seen also in the field? Maybe just speak to that if you can.
Okay, so we've taken the 8-hour analysis, but we have a team of people that go into threshing. So they take turns, but the machine doesn't go off. So effectively, there's resting time there as people thresh during our exercises.
I'd add that and James, you can respond back on the throughput. The throughput for maize among the 15 operators that we looked at of your operators was significantly higher than the 2,000 kgs per hour. And I guess that was achieved by this efficiency where you were constantly feeding the thresher and you had teams going in and out. Is that why the rates of threshing, maize rate threshing were north of 4 tons per hour?
Yeah, so the feeding component, like I indicated earlier on when responding to one of the questions, is critical when it comes to the output of the thresher. So just last week itself, we managed to do 2.5 tons in 22 minutes. And that is owed to the fact that we constantly were feeding the thresher on maize, that is. So based on our calculations, we should be able to do about 5.5 tons of maize per hour. Yeah.
Great. Well, thanks everyone. We actually have a lot more great questions, but we do need to wrap up. We're rolling into the next, the final session of our symposium at the top of the hour, which focuses on gender. So just to let you all know, if we didn't get to your question during the live webinar, we will definitely write you back via email and give you feedback from all our panelists, and we can keep the conversation going. So I'll turn it back over to you. Thanks, Amy.
Yeah, thank you, Courtney, and thanks everyone for the questions and to our panelists. So this concludes the second session of our multi-crop thresher webinar symposium on profitability. Thank you so much for your participation. Please consider joining us for the third session, promoting gender equity and ownership, which is beginning shortly. The link to register, if you haven't already done so, has been provided in the chat box. Today's webinar has been recorded, and a link to the recording will be sent to you in a follow-up email. When you exit the webinar today, you'll be asked to complete a short exit survey. We really appreciate all of your feedback and the time you've spent with us, so please just take a few moments to complete this survey. Thank you so much for joining us, and have a great rest of your day or evening.